work? Yes. I'm actually live. Oh my god. Hamburger. Hamburger indeed. That's what I'm saying. Happened there. Is that actually now, or is that like? I'm gonna be shocked if there's a person here this quickly. My mic sounds quiet, I think. What about that? We'll see. Right. I'm gonna send the stream to people. Yeah, sure. I'll take that. I'm gonna try a thing here. I'm gonna do a YouTube community post. Say that I'm live. I don't know if that's like a done thing. No, man. This is all new to me. But while we're here, I talked a bit in my video about greedy meshing for optimizing voxel worlds, where you take faces that are next to each other, and you combine them into less faces to save vertices. I need to do that. That's really, it's not a very intuitive algorithm, especially not to do performantly. So that's my current mission, is to look into that. Oh, I can hear myself. No, go away. Let me share my live. Posts. I was gonna wait for you to be late so I could get on you for being late. I wasn't late though, was I? I was here. I wasn't even a minute late. I'm that good. I'm that good. Spat on myself. We're gonna ignore that. Right. I've done a tag on Discord, and I've done a community post. What more can we even want? Should we explain what I'm doing today? All right. This is some pretty heavy shit. I've been fucking around with turrets and everything recently, and that's easy. You know, that's like, here's a bunch of systems I already have. Let's tie them together and make some stuff happen. 3D meshing is something that like I have no basis. Do short stream, it helps you grow for real. Oh, short stream. What does that mean? Like end stream now? Is that yo man, what's up? Won't be staying for long because I have an appointment with the doctor. Just want to say that I really wish to see your game. I hope it does well. Looks a lot of fun. Take care. No worries. Thank you so much for stopping by. It means a lot to you say that. I'm really glad that you enjoy it, and thank you very much for wishing it. I hope you can get it when it comes out and have fun times. It's like YouTube Shorts, not like the amount of time. Oh yeah. I'm doing shorts of the streams. They're up already. A few of them. I've done like 1 or 2 for each of the streams I've done. They do all right, but it's one of those things where it's just pumping stuff out as much as I can, and then eventually one of them is bound to do good. I'll sure buy it. Thank you very much. K Code, when will you add DEI to build fight games? That's a good point. Soon. I'll add the woke. Should we? Right, greedy meshing. You've got your voxel grid here. I want to do this on a separate layer actually. Here's your voxels. Also, is this a YouTube long? Yes, this is a YouTube long. It took me a while to understand. I just said that. Effectively, if we've got 4 voxels here, this is the same thing as just having like a big mesh here, which means that we can take 16 vertices and condense it into 4. And the savings with this are huge because the more that you combine, the more you're saving. You know, like we have this. Well, that's the same as this, which is still 4 vertices compared to, what is that? 4, 8, 12, 16. What's 16 times 4? 64. I should know. That's powers of 2. You've got 64 vertices down to 4, and this just goes on forever and ever and ever. So, yeah, we need. That's a big performance improvement. I talked a bit in my devlog how I made a system for that in the past, which did work. It was too slow. That was baked into an Octree based system rather than the current chunk based one. So I've got to think about how I'm going to do this. It's tough. It is really tough. I honestly don't particularly know where to begin. I think what I'm going to do is I'm going to start a new Unity project and do everything in there. Just because I want to have less of the baggage of build fight game, and I don't want to be worried about like making stuff not work. What I want to do first is make sort of a proof of concept version, then convert it into something that works with Unity jobs, because Unity jobs is responsible for running everything in parallel and making it super rapid. But I just need to first go like standard C#, slow-ish algorithm, proof of concept for greedy meshing. Project with the sort name already exists, greedy meshing 2. Because I have, in fact, already given this an attempt a few months ago, or probably longer than that now. Oh god, I love waiting for Unity to open. Is this entertaining? Sorry, Unity is creating a new project, which takes a while. So, are you entertained? That progress bar is looking thin. Probably should have done this before I started stream. I always forget how long it takes to make a new project. Isn't this good? It's speeding up now. I'm not showing it because it's only on like a small splash screen and you see OBS more than that, and I just like that conceptually. That's my thing. OBS is for me. It's coming. It's coming. I can see losing that one. I think I might have just lost the one viewer, but it is loading. I feel like my mic is too loud. I think it keeps. It's too loud and too quiet. I don't know what's up with this. I'm gonna drag a diagram just drawing of how you could optimize your game. It should be simple to understand. I don't know if you thought of it or not. It's not culling. It's good to me. Where's that? Well, like frustum culling. So only rendering the stuff within the camera view. I already do that. Frustum culling. It's it is a good optimization. Oh, I haven't drawn it yet. Okay, fair enough. Sorry, I thought you meant like you had that ready to go. So it depends if it's frustum culling or occlusion culling. Frustum culling could do. Occlusion culling, I think, would be tricky to handle in terms of like one thing that the map and build fight game, most of the stuff isn't. There's not much being included anyway, so I'm not sure like it would really save much. I think frustum culling is the big one. God. Unity really need to work on this. I'm very acutely aware of like how long this I've been waiting for all this. Ugh. There we go. A project. Now, let's make some scripts. I'm going to copy the block data from build fight game. As much as I can. World block. There goes the dog because there's a car outside. A lot of this is going to give me an error. But... Actually, is there anything in here that it can't? No, that's fine. Cool. Right, so all the block data is alive, which is what I need. Then you have this class, which is going to have to return. We got to think, all right, that dog is... Please stop. Oh, thanks, Bat. You know, actually, let's make a struct for the world, for the data. Which I have vertices, triangles, and normals and UV. I think I'm gonna get up actually the chunk script for Code Fight game. Yeah, that's... So this is the thing in build fight game that actually does the turning the chunk into a mesh. It's kind of ugly, but it kind of has to be for sake, because all it's doing is basically shifting numbers around. And this, oh god, she really doesn't stop. God, I haven't touched this in a while. Indices, vertices, normals, UVs. Yeah. There's another thing here. I'm pretty proud of this. What I've done is I've made it so as like part of each vertex in the mesh, it stores in a separate unused UV channel. It stores the data for the actual block, like what block it is, which it uses to fetch a texture. Which means that I can have one shader for the entire chunk, which depending on what an individual block is, will assign a texture. I don't know how much sense that makes, but like, it's clever, trust me. So a couple of issues that make it hard to do meshing. A chunk is just an array of blocks. So it ends up being 3D, but because it's 32 by 32 by 32, it's always the same size. We squish it. I'm gonna change the namespace on here. Get rid of it. Oh shit, that's the wrong thing. Ugh. Don't want that. Don't need that either. We need to go from an array of chunks, an array of blocks even, to all this mesh data. Much easier said than done. Oh, it's gonna require some thinking, and this, I imagine this is gonna be a much less entertaining stream because like it's just gonna be a lot of sort of this makes no sense. I don't know why I'm cradling a bottle like that, like a fucking. Private struct. Can't have a public method return a private struct. Obviously. Now, when I see this, my first sort of thought is we kind of go layer by layer on each potential face. Like, we go through each block. How do I describe this? So, a cube obviously has 6 faces. So imagine you've got your chunk here, 32 by 32 by 32, and this is just abstract effectively, which has some data in it that we need to turn into a mesh. So first of all, we're going to do all of these faces for every block in the chunk. So we're iterating through every block 6 times, I guess, kind of in slices. So first of all, we take a chunk, this sort of slice, or hang on, this slice. Then we go here. Is there a block next to me? Here. Yes, there is. I'm going to expand to the right. Is there 2 blocks below me? Can I expand to the right? If so, I'm going to expand to the right. Can I extend down? I'm going to expand down. Can I expand to the right? I'm going to expand to the right. Repeat until you can't expand either way. Then you go to the next layer. Then you go to the next layer, then you go to the next layer, rinse and repeat. And then you've done all of the faces for that. So then, let's say we want to do... So now we've done this, all this set of faces. Now what we're going to want to do is we're going to do this set of faces. We do the same thing, right down, right down, right down, until we've covered every block. And then you turn it in general. I will have a look. You make it so your program... Yeah, so that is build fight game already does that. So if you have neighboring faces, they don't render, which is a massive performance improvement, specifically with voxel games. Like you are, it's not a big deal for most games. You're right, but in voxel games specifically, it is like the biggest reduction. But I'm saying like it's still not enough at the moment in build fight game. The game just does not run as well as it should, and like. Performance-wise, in terms of the code, I've got everything down as much as I reasonably can. I mean, I say that, I'm sure that, but the biggest bottleneck is just there's too many goddamn vertices, and there does not need to be so many. So, actually, I say this. I think we only need to go through each block once, but then do no. Let's just try doing one face. No, it shares like the same coordinates. Not culling, I think. Text the nearby lines, it combines the vertices. Oh, okay. No, I do see. Yes. Okay, that is indeed not a big deal. That's like. So for one thing, that creates issues with normals. Because meow indeed. Meow. You can't have. Maybe that would work. Hang on, fuck. That's exactly what I'm doing right now. Is this game inspired by Infinity Miner? Kind of indirectly. Like I've never played Infinity Minor or been into it, but I know that there is a lot of overlap. I think we come from the similar sort of inspirations. So not purposely, but like sort of. But that, yeah, so detecting the thing you post is kind of what I'm doing now. That's what greedy meshing is taking faces that are next to each other and making them into one face. And that's a big old reduction. So I guess for now I'm just going to try this with like one set. Okay, so let's just do front face. Front faces. Think about it. Okay. Go through all the box. No, I don't want a for each loop. I want a for loop. So is it sharing or not showing the faces? I don't care how to explain it. Well, I think what you're describing anyway is kind of made obsolete by what I'm doing. So effectively, if you have two, yeah, got a face here. Why the fuck is Memo's paint? A face here and a face here. Well, what you can do is that's just one face, right? Assuming that these are the same block and therefore have the same texture and shader and everything, just do that. And then when you end up with like a massive mesh with a bunch of stuff going on, this can be a big improvement. Like what I'm thinking of is water, where in Build Fight game you have this massive mesh of just flat water for the ocean, and I'm thinking like you turn that from what 16 by 16, so there's 24 vertices per cube times 16 by 16. Let me see. Okay. 4. Yeah, that's 6,000 vertices, and it could just be 4. Well, I mean, actually, that's not accurate because it's only showing the top. So, but even still, 1,000 vertices per chunk that could just be 4 vertices. I don't know, guys. You heard it here first. 4 is smaller than 1,000. But that's what I'm trying to do. It's just the actual code involved in that is a bit funky. Because like say we've got a big grid. Like this, and then something like down here. Kind of same thing I'm talking about, but it's not combining. It's the same vertices or chords, but also any Z buffering. Not really. I'm not sure what you mean. The same vertices. I don't know. So does your thing like is that going to work with greedy meshing? Because that's kind of like the main performance improvement. So on the grid here, I can explain to you off stream. Okay, cool. So effectively, if we're iterating through the array, it goes like 0, 1, 2, 3, 4, 16, then down up to 32 in VC if you want. Yeah, cool. So go up here to 32, another 32. It's in 3 dimensions, but I guess in this instance it's only a slice, so it would be in just the one. So if we're greedy meshing, first we're going to say, can I go right? Can I expand to the right? Can I combine these? And you say, yes, we can. So, bosh. Now these are here. And then you say, can I expand downwards? Can. Okay, great. Can I expand right? No, I can't. Can I expand down? Make this a bit clearer. No, I can't. The issue is here. Where do we advance to? Well, I guess we go here, but this is already accounted for by this. So how do we do that? I mean, you could have just a big list of indices for what's covered and then check that, but that feels really inelegant and like it would get slow quickly. So what do we do? Right. So what I'm going to say we do, work. What I was thinking is if we have like a, I don't know, like a sort of values saying like next voxel. Or I guess, could we have right voxel index and lower voxel index? So here that's going to be 0 and that's going to be 0. And then every time you advance to the right, so this is going to be 0 and this is 1, and this is going to be 33, and this is 34. So 0, 1, 3. Every time you advance to the right and you combine this. So once you're handling 0, you increment the right voxel index. So that becomes 1. Then if you combine it, you're like, oh shit, I can combine this with 1. Then you've handled 1, so you set the right, so you increment the right voxel index again, 2. Then we check, can I go down? So for this, we're going to have the kind of current one. We need to check, is this and this. Oh, actually, so first of all, we need to set this to 33 once we're doing kind of 0. For reasons which will make sense later. So we check, can I go down? It's going to work. What I'm describing working. I'm really trying to wrap my head around this. Is hard to do. Maybe I need to look into this a bit more. Because it needs to make, it's basically, it's just making sure that every voxel gets looked at. Okay, so what I'm going to say here is if it can go down, we take the biggest one that we've just deleted, which will be 34. And the next index, the lower index, is going to be that plus 1. So it becomes 35. And then I guess we set the current sort of head to the right voxel index. It's going to be 2. Really trying. I think we may need to wait until tomorrow because my nose is running and last thing you want to do is hit me sniff my... Yeah, fair enough. You know what I could use here actually to help me sort of wrap my head around this. I'm gonna basically just need a random noise texture. Actually, I know what I can do. Skip MS Paint. Oh, it says Extra Flux. Hello, Extra Flux. I'm losing my fucking mind trying to figure out how to make this work. Right, we're hearing Krita instead of MS Paint because I think I need something to help me along with this. Right, good. Krita, is that cocaine you're drinking? Yes, it is. It's crack cocaine. God, where is it? It's artistic? Anyways, as a computer science major, I don't fucking know nothing. Then I'm going to take this and make it black and white. What I want adjustment curves. The reason I'm doing this will make sense in a second. Right, so if I'm greedy meshing, what I want to do is set it so all the white pixels are. I'm making Perlin noise. All I'm doing right now is making a black and white noise map. Do little emoji reactions do anything, or am I just making hearts appear on my screen? They appear on my screen too. Thank you for the emojis. I don't know who's doing them, but like I can see them. I'm making a noise map so I can wrap my head around how I'm going to do this. I'm trying to basically run the algorithm in my head to figure out if my current sort of plan is working. So here, it's nothing. So we just advance the next index. And then check the right. Then we check down. Can't go down. Can we go right? We can go right. Go down, we can't. Go right. Can't go down. Right. And at this point, where I want to be is here. But how am I going to know that? Because within just the regular for loop, the index is still here. So what I'm thinking is every time we go to the right, I'm going to increment this like a next index, which is going to be +1. So every time I expand here, so the current index is 1, the next index is going to be 2. So I expand here, I go so it's 2 right now. Now it's 3. Now it's 4. Now it's 5. Now it's 6. And 6 is here, which means that once I'm done with this, I know that I can jump to here. This is fine for just doing a line, but I also need to go down. So where can I go down? Here. So here my next index is good. I mean, I don't know what the actual value is going to be, but if we just assume that we've got a 2D thing here, 0. My right index is going to be 1. So doesn't work actually. Here, this works. So I've got my sort of right index and a lower index. If I move, I can't expand to the right, but I can expand down, keep expanding down, and this whole line becomes 1. God, this is really fucking hard to do because the next value here has got to be this, right? But imagine I have like, do you only combine the faces if it's the same, or do you still make them into one mesh as long as they're on the same elevation? So you combine the faces if they're the same type, if they're the same voxel type, because of I'm sure there would be a way around that, but effectively it's if you have like a flat plane of these voxels, combine them all into one as long as they're the same. But there might be a way around that, but the reason for that is because within my shader I have the block ID baked into the vertex data so that I can access it within the shader really quickly without having to do any fuckery. It's just part of the second UV channel because that's not used by any actual textures. In fact, I don't even use the first UV channel anymore. All the blocks use a sort of variation of triplanar mapping, which is just normal value and kind of makes UVs off that. But what I'm trying to figure out here basically is like, I don't know, if I've got this big glob here, and that goes like, or it would end up going like, right. So I need some way to make it clear that I need to process this voxel. I don't need to process this voxel, and it's like, God, there might be some genius solution to this, but in my head, all I can think is I'm gonna have to do like a list of voxels that have been dealt with. I really don't want to fucking do because that's slow. Lists are slow. I need this to be fast. Okay, I won't use a list. I'll use an array because I'm sure there's some video explaining this or something. See, this is the thing. This is like a really niche or niche-ish topic. There's videos explaining greedy meshing conceptually, but like a specific implementation. I'm gonna Google it right now. I've seen bits of it, but like It looks like they're doing pretty much the same thing I'm doing. Like, I mean, like I can find a GitHub script, but I don't just want to copy. Yeah, so they're doing exactly what I'm getting here, which is instead of using a list, you have like a array the size of the whole thing, which tells you if a chunk has been an individual voxel has been processed or not, and you do this for each axis. Never hurts to look at someone else's code. Yeah, exactly. But I'm just at the moment trying to get my head around the kind of most basic principle. Drop my water ball. Fucking, I'm all over the place. Oh no, hang on. So he's creating a mask. Like each slice of the chunk one at a time. That's what I'm doing. Okay, I don't know what this guy's doing. Ooh. Doing, I can get this up. Do some general research. This is links I've clicked before, but just looks. Oh, this article I always fucking back to. Hi, Oscar. This is JavaScript, but it still works. The fuck is some code gen shit? What is this? It's beyond me. Mm. And the important thing is, I do not need it to be the 100% most optimal solution. I just need it to be better than it is right now, and still perform. Hmm. I know I'm being completely silent, but like I'm trying really hard to think. Hmm. It's cool. I fucking hate JavaScript devs. They always use just single letters for the variable names, and it's like, call them something. Call them something good. This is like, ah. Right, first of all, what the fuck is lexicographic ordering? I am not. I got my maths GCSE and I stopped there. What does that mean? A way of comparing sequences by examining their elements from beginning to end. Comparing variables in specific order based on their values, allowing for efficient constraint propagation in computer. This is beyond me, to be honest. Hmm. Get my screen back up. God. Scan across in 2D until you find a face. Try to keep extending that face along your scan until you have to stop. Then see how far you can send that road down into a face. Thinking it's so hard. It is. Then mark those faces down and emit one big face. Well, yeah, that's kind of what I'm trying to do. But how the fuck does that do this? Like, what are all of these? You're just like, what is this? Hmm. I think I might have to do this my way. Maybe. No, because there's no way that what I'm trying to do is going to be performant. This is. But it's just like, what the fuck is this? Okay. Oh, that rule. Demos. C#, that helps. Voxel engine made in C# for Unity. Okay. This is a guy who's much more intelligent than me. Where's he doing the actual generation? God, these people are like fucking wizards. They make me feel so like inadequate. How? Where's he actually generating the meshes? Like, this makes sense to me. Everything he's doing. I mean, he's doing a lot of get component calls. Probably cache that. But also, so you have a mesh collide. Have a renderer you're setting up. Mesh is new mesh. Map hand world. Whoa, fucking hell, this is definitely it. Right? This is something. That's fun. Whoa, that is a lot of bytes for a single block. Build fight game would never. Yeah, this guy's clearly a fucking doesn't. Yeah, whatever. Bitwise shifting and staring it like that. Mono develop. What a fucking blast from the past that is. Oh my god. I'm going on a side tangent here. I mean, when was mono develop last used? Mono develop was like the fucking IDE that came with Unity, and I can't remember when they stopped using it. I just barely remember it. What a fun 2018. My god. Have you seen the Minecraft milk law? Why milk out of everything and why green in Minecraft? What? I don't know what you're referring to. Creeper milk. Ugh. In Walmart, they sell Minecraft milk at the milk part of the store, and it's green in. I did not know that they sold Minecraft milk in Walmart. Is used. My God, this really is something. Fucking. I'm gonna download this. Writer open. Okay, so you're iterating through every world position in the junk. Getting the sort of idea of the block. Bit shifting. I do the same thing in build the game, but heck if oh, this is I'm fucking burning up and I'm gonna die. I might not actually be able to stream for that long just from like virtue of my brain exploding. I think I need to give this a think. Draw block. So here you're adding. This isn't greedy meshing, surely. This is doing everything that. Yeah, here you're adding x times block size plus. There's one triangle. So you're doing two triangles here. So this is one face. So maybe this is greedy mesh. But then, so does this value change? Or is that constant? Right, block size is a constant. So x times block size plus block size times max y, max x. Right. This guy's fucking naming conventions. I can't tell what's local and what's not. Max x is 0, so... Okay, so he's going... So this is the block going through the chunk. If it's the same block and hasn't been drawn. Oh, so no, so this is exactly what I was thinking of doing. Right? Where I have a sort of a bit, like a mask for each slice, which says what's been drawn or not. Okay, so if it works for him, it worked for me, I presume. Yeah, so go from here. What the fuck is this doing? You're essentially scanning left to right, then down. But Z is Z. Z is less than chunk Z. I like taking the griddy on a regular basis. Me too. I'm not hitting the or anyone suggest that. Yeah, so blocks is the array of blocks. So how are you moving it down? How are you determining if it's... Oh, so that's going to move it along one. Then determine if this is it. All right, so if you're at position like 5, you're going to go 5. Check if... Check if the block you're at now is the same color, hasn't been drawn. If it has, then the max is going to go up. So we're expanding to the right. Then oh, so this is effectively going to go down, then across. Yeah. When it's first iterating this is going to be operating on itself. So presumably that's going to be true. Or yeah, so it has been drawn. So, well, no, because that'll break out of it. Okay, so that's fine. So it's on itself. The max X is going to increase, but you're still on this sort of 0 value. Then the Z is going to still also stay the same. So isn't this effectively doing it in strips? No, it's not. Right, I think I'm just going to have to do it my way. No, I can't, because mine is doing it 6 times, whereas this is not doing it 6 times. Is it doing it 6 times? No, this is just iterating through blocks, doing triangles, then kind of doing the same thing on each. Takes a block. Oh, fucking hell. Jesus, this is the probably the like I cannot remember a time having to code something like just this kind of, because there's no, the documentation on this is it's not non-existent, but it is not extensive, you know. A lot of it is just you're on your own. There is not an easy way to do this. Fucking birds. I can see birds outside. Okay, so key thing. We want to reduce reading from memory as much as possible, which means I only want to go through each block once. So for each block we do. Could we? Right, here's what I'm thinking. We have an array of bytes. But so for each of our for every chunk, when we're generating it, we create an array of bytes. So that's going to be for each block, there is a byte representing which faces have been drawn. So what you can think of these bytes as is a bunch of little Boolean flags. Now, we only need 6 of these, so pop these last ones off. Each block has 6 faces that it can sort of have taken care of. So, for our algorithm, instead of just saying has this block been dealt with, we can say here are all the blocks and here's which faces have been dealt with. So if we're iterating along one block, we can move out, and the block that it's just done, we can say this face has been registered. So this is going to be completely arbitrary, but we've got a north face, south, east, west, up, down. We can do a bitwise AND operation. North face. That's crazy. Can we do a bitwise AND operation? What do we need to do for this? If we've got like how do we make this work? I'm trying to freaking my knowledge of like binary stuff. I'm just saying, imagine, so this is our block, and we want to check if it's been on the north. So we just basically need to know this specific bit and this bit, and those. I suppose you could just bit shift it. So if we shift this to like beep, and then beep, then we can AND them. And then if you have like 0, 1, 0, 0, 0, 0. So, you know, if you want to check if it's south. No, so you would do a bitwise Parkinson's. I don't have Parkinson's. I've got no Parkinson's. Oh, my fucking brain is about to fall out my ears. So here I want to check. Has this block been southerned? Is it on the south? And if it's like 1, 1, 1, 1, 1, 1, it's true. So I guess we do a bitwise AND, and then we just have to read the specific value. So this is going to be false, and we do a bitwise AND here, and it's going to be 0, 0, 0. No, wait. So we do a bitwise AND, and if it's not 0, that means that it's the direction that we want. Great. Okay. So first of all, we need some constants. How do you I can't remember how to write binary in C#. OB, that's what you are. All right, so I'm going to say north is, there is 1, 2, 3, 4, 5, 6, 7, 8. Why is that not working? Oh shit, because I can't. I'm in the method. South is this. East is this. West is this. Up is this. And down is this. And I'm going to indent these so that they're... Let me indent, please. Then I'm pressing tab, man. Alright, well, it's not letting me indent them. So I'm going to use spaces. Alright, we're just going to have a constant for chunk resolution. And then at the start of any mesh data, we want to clear it. Realistically, when I get around to jobsing this will probably be a temporary allocated array or whatever, but not for now. Actually, you know what? Fuck it. Right now, we don't need performance. We just need the principle of getting this to work. So we have block states. Iterate through each block. So how does this need to work? We need to figure out how far each face extends. So first we need to tell if we need to render this at all. If this block is surrounded by other blocks, just fucking, because it doesn't need to be. So before that, we need a helper method. And before that, I need to piss. Ugh. Big piss. Absolute banger. My best work. I can't find my right shoe. I'm going to be late to rehearsal. Good. PTK code stream is more important. I'm going to turn up the exposure on my camera because the sun was a bit higher up when I started stream. Although it does kind of reflect my mental state pretty aptly. Now, I'm going to yoink another classroom build fight game. This. Up 18 minutes. Huge. How much storage does the game take up? I can't actually remember. It's a good question. I am gonna reinstall the game on Steam right now and see currently what a fresh install takes, because my install is gonna be slightly larger because it's got a bunch of stuff that like Unity builds that doesn't end up getting shipped. So I will uninstall it. I'm gonna get off my phone as though. No worries. Thanks for coming along. Good times. I found my answer. It's 1.68 gigabytes. There it is. Thanks, man, for the entertainment. I don't know if I'd call this stream entertaining, but you're very welcome. I have tried. So we've got our block. Well, block. What do you think the minimum session recommended specs will be? So tricky. I'm gonna find what I put on the store page for you, because that's kind of what I'm aiming for. You know, 8 gigabytes of RAM, because I thought the game would be pretty RAM intensive. It's actually not, so you could feasibly play it on less, but like, let's say 8 gigabytes. Otherwise, you won't have a great time. It's mostly CPU bound, so you kind of need a decent CPU. Like, I don't think that should be the minimum, but still. i5, like i3 sort of thing. Well, no, we'll call it an i5. I don't know. It's hard to quantify, basically, but I want it to be able to be like potato kind of PC. Not Minecraft, because Minecraft is really potatoey, because it's, you know, it's a 2009 Java game. I think it will be more intensive than Minecraft, but like not massively so, is my hope. But as it stands right now, it is not nearly as optimized as it needs to be. Hence, here I am, putting myself through all of this. Every port on Recon's nodes will be modeled individually. True. Fully modeled. Oh god. Like something else. Like something else. Okay, so for starters, let's just do the north face. That's gonna be on the Z. We need to go out in the X and directions. To the right. Right and up. So we're gonna go Y first, because that means it's last, basically. I don't hear that makes that true. Whatever. One time Peter shot me in a Costco parking lot because I said the F word. Yeah, that's true. No swearing. No swearing, guys. Any specific parts of the game you want to optimize, or you just want to try to optimize everything? Well, right now, this is what I'm doing to optimize it. Is the greedy mesher. So this is effectively a massive saving on the voxel like vertex count. So that's because right now I'm profiling it. All my code is reasonably efficient. The main draw is just on graphics, and it's not. It shouldn't be a graphically demanding game, but it ends up being because as soon as you set your voxel distance quite large, it's like just the sheer number of vertices is insane. So I can go over it again because I'm presuming you weren't here for it. Effectively, if you have like a bunch of vertices, like you've got these three voxels here, right? And these are all the same voxel. Well, you can just as easily represent that as just this. You know, so you've taken 12 vertices and you've turned that into 4. And this is a pretty massive change, especially like the more you get, because now you have all of these, and you can just easily turn that into this. So it's the same representation, but 4 vertices instead of 36. Big. The main saving with this will be with the water. So the outskirts of the Build Fight Game map, you have a big ocean, and the top of that ocean is pretty much just flat. But every single one of those ocean blocks is 4 vertices, which is 4 vertices times 16 by 16. That's 1,000 vertices per ocean chunk. Oh shit, no, the chunk's bigger than that. 32 by 32 by 16 per ocean chunk. No, I 32 by 32 by 4. You have 4,096 vertices per ocean chunk, right? You do it this way because it's all one big cube. You turn that 4,000 vertices into 4 vertices, so 1,000 times less in under sort of ideal circumstances. It's a pretty fucking big saving, which hopefully will, as well as just improving the game's performance, it leaves me a little bit more wiggle room everywhere else, and I don't have to be like so down to the wire on performance, because pain, like right now, I'm sort of squeezing bits out of everything just because this fundamental voxel code is not as well. The code is very efficient, but the meshes that it produces are not. But it's a tough algorithm to write, is what I'm currently facing. I guess so. If I'm here right now, I want to check this. Do you think it's harder to optimize your game in Unity than it is in other game engines? Not really. I would say it's easier, actually. I think for a voxel project like this, the best options are Unity or no engine at all. Because Unreal is very graphically demanding by default, like it just inherently, because it's trying to look pretty. Godot doesn't have the performance saving features that Unity has, and the shader features that Unity has. Like Unity, you have the job system, which can parallelize a lot of things for you. You have so much like intermediate shader languages. Like you can just write stuff in HLSL, and there's so much it does for you. Godot, as far as I know, like if you want to do multi-threaded code, you're writing it all yourself. There's nothing that it will help you with really. It doesn't have as many shader tools. It's so much harder to write shaders in Godot. Like writing shaders in HLSL in Unity is a challenge, but it's like much easier. Godot and also, you know, there's a shader graph, and Godot doesn't have anything like that as far as I know. So I would say that it's actually probably the easiest to optimize something like this in Unity. So I'm iterating through chunks, trying to calculate the north face of a block. So first I need to say, am I air? Hang on. I'm going to call this root block. And then we're going to call this current block. It hasn't been long, but I might call stream soon just because my brain is exploding from trying to figure this out. I don't know if it's the sort of thing I can do live. But this is actually really... It doesn't exist. That's hyperbolic. It very much does exist, but this isn't one of those things you can just Google it and find some sample code that works, or like an in-depth tutorial. You find a blog post that tells you the theory, but it uses words like lexicographic ordering. I don't know what fucking lexicographic ordering is. You can find JavaScript code that does it, and it's like all the variable names are just like letters of the alphabet. It's leave me alone. So I'm kind of flying blind here a little bit. It is tough. I don't think the way they're doing it is the best way to do it. I'm gonna do my own thing. Thank you for believing in me, Extra Flux. I do not believe in me. I kind of believe in me. No, hang on. I'm going to try and move it to the right. This is just going to be... I'm trying to write the code just to do one like little thing. Don't draw it if it's air. So we're going to continue. So for the same block, in actual build game, this is use something called vis. No, it wouldn't. It would block ID. So that is correct. For the same block and block states index. I've got the biggest, greediest mesh around. My mesh is greedier than yours. I guarantee it. Apply. P2K codes in McDonald's right now. McDonald's says hello. Hello, McDonald's. Thank you. This means that we can expand it. Right. So is this where we're trying to expand it down, I suppose? So we're going to check if this is here. Here. On. But I don't want to do it once. I don't want to go like, and then, I think I might need a while loop for that. Or is this what they were saying in the paper? Like, would it be better to do the all the way down, then all the way to the right? This chat is AIDS, or is. I love it. I would not have it any other way. See, I'm trying to. If I get my noise texture up, would it be better? Is it better? What's my mouth? Is it better for me doing this to go right down, to go right down, right down, right down, etc., or to go down as far as I can, right as far as I can? Intuitively, I'm thinking that it's best to go right down, right down, right down until you. No, so if we take this instance here, that would go as far right as it can, which is up to here, and that's one mesh. Then as far down as it can, which is nowhere, so that's the mesh. It would get to this spot. Take it as one thing. Another mesh here, which is 4, 8, 12 vertices. Whereas if it did the flood fill, like sort of, it would go. Well, that's actually the thing. But if we, let's say we do the other all the way down, I don't think it matters. I think you can just go like let's take this example. Yeah, I think it ends up with sort of larger areas. I do think you can just go like all the way across. Yeah, so this is going to go down and then across. can't see that working. All you're checking is the one that you end up with. This is blowing. This is. Oh, fucking hell. Right, so I guess what I've got to do here is go. Oh. Okay, so X bound is going to be 0. Y bound is also 0. So, first of all, we check if this is a different block to which it's itself. So this is going to always return false, but it doesn't matter because it's part of the iterative set. If this is a different block or this face has already been generated, don't worry about it. But this is false. So we're going to go here, which is going to start this while loop. Or actually, we'll be starting here. Which is going to go up until it finds a block that satisfies this condition, which is going to be up here. So that's your kind of Y limit. And then you go a step in the X direction. Yeah, but this is why it doesn't make sense to me. Because you're only here checking this value or this value, but you need to check all of these. I mean, I can do that. And does that make any sense? Not really, no. Fucking Christ. How long have I been streaming? Hour and a half. Ugh. This is what I was doing back when I was like streaming Broken Home. It's like sort of silent coding. Yeah, I think I'm gonna end stream just because this is not interesting. This is just fucking bashing my head against a brick wall. God. Thank you for those of you that did come. I really, this has not gone great. I mean, it's fine. Like I'm not worried. I'll figure it out. It's just not something that. It's just something I'm gonna have to put a lot of thought into, you know. Oh fuck! I forgot to. All right, I'm getting no clips out of this because I forgot to record. And Jesus, OBS is fucked up. My camera looks really delayed. That might come across the stream, might not. Anyway, thank you for coming. Etc. etc.